Today, we dive into the first module of our journey, which is titled Introduction to Python Security. As the digital world continues to evolve, it becomes exceedingly necessary for every developer to understand and implement security measures in their coding practices. This module provides a comprehensive overview of Python security and underscores its fundamental importance. In this module, we will navigate the security landscape of Python, one of the world's most popular programming languages. We will primarily focus on understanding the vital security concepts inherent to Python programming that every developer should be equipped with. This will not only enhance your coding expertise, but also give you a solid foundation towards becoming a responsible Python developer who places a premium on the security aspect of their applications. By the end of this module, our aim is to ensure that you have a clear understanding of why Python security matters and how you can leverage this knowledge in your respective projects. Buckle up and thrill yourself as we embark on this enlightening journey into the world of Python security. Remember, no knowledge is ever wasted. Alright, let's dive into the core of our discussion. Presently, we'll be focusing on Module 1, Introduction to Python Security. In this module, we are going to examine the importance of Python security and why it matters. We'll start by understanding why securing Python applications should be a priority. Given the widespread use of Python in software development, it's crucial to reinforce its defenses against potential cyber threats. As we proceed, we'll also introduce some key security concepts essential in Python programming. These concepts will lay a solid foundation for Python security and guide you in developing highly secure Python apps. Now, imagine having a Python application that's resistant to threats and vulnerabilities. That's the goal here, to ensure that the code you write has a robust security posture and that the integrity, confidentiality, and availability of your data are upheld. Stay tuned as we unravel more about the significance of Python security in the next module. On our current slide, we are delving into the overview of Python security concepts. Essentially, the merits of implementing security in Python can be summed up in two broad categories. Firstly, it shields your Python application from potential threats and vulnerabilities. Examples of these threats could range from unauthorized access to malicious code injections. Secondly, it vouches for data integrity, confidentiality, and availability. This means, whether you're dealing with customers' personal data or companies' internal data, its accuracy, secrecy, and availability is ensured at all times. Under the umbrella of Python security, there are several key concepts, starting with secure coding. This involves penning down codes that are resistant to hacking. The idea is to design and implement software that wards off any malign attempts of disrupting the functioning of your applications. Next, we have encryption. This is one of many powerful tools to maintain data confidentiality. Encryption, to put it simply, is just transforming the data into a format that can't be understood without decryption. The last concept we are talking about here is authentication and authorization. While authentication is the process of verifying the identities of the users trying to gain access, authorization is the concept of verifying their access levels. It decides on what operations the authenticated user should be allowed to perform. To summarize, the purpose of security in Python includes protection from threats, ensuring data integrity and availability. Key security concepts envelop secure coding, encryption, and verifying users' identities and access levels. These concepts ensure we write secure Python code that's unfazed by the persistent threats in today's cyber landscape. And let's dive deeper into aspects of Python security, beginning with secure coding. The intention behind secure coding is simple. We want to minimize the possible security vulnerabilities present within our code. If we, as Python developers, follow certain practices, we can maximize the security and reliability of our applications. The first of these practices is input validation. Remember, not all data received as input can be, or should be, automatically trusted. Empty fields, unusually long data entries, or entries containing special characters could all be potential indicators of a security threat. Therefore, validating all input data is a preventive measure against such threats. Next is error handling. While it's important to address and resolve errors, we should also understand the potential risk involved in error message disclosures. Sensitive information could inadvertently be exposed during an error, potentially exposing your application to malicious users. Hence, error handling, while useful, must be done cautiously. The third is adhering to the principle of least privilege. In other words, Always give the bare minimum level of access or privilege necessary for a task to the components of your system. This principle serves as another precautionary measure, limiting the potential damage if a particular component is compromised. By strictly following these best practices of secure coding, we can effectively enhance the security of a Python application. Remember, a secure application not only safeguards sensitive data, but also fosters user trust and legal compliance. Now, let's move on to our next topic, encryption. Encryption is a critical aspect in Python security. Essentially, this involves transforming plain text information into a format that can't be understood or deciphered, which we call ciphertext. The main goal here is to ensure confidentiality and prevent unauthorized access to sensitive data. Python supports numerous modules that aid in implementing encryption. Some of these include HashLab, PyCrypto, and N2Crypto. To provide an illustration of how an encryption process works in Python, let's consider an example using the HashLab module. In Python, you could import the HashLab module and then create a hash object. For example, import hashlab hash object equals hashlab.md5b hello world print hash object.hexdigest. Here's what's happening. We're first importing the hashlab module, which contains a variety of different algorithms for hashing. Then, we instantiate a hash object using the MD5 hashing function. The string hello world is passed as bytes into the MD5 function, which then outputs a hashed value. Lastly, we print this hashed value. This command would therefore, in practice, transform the string hello world into an encrypted format that is unintelligible. This is just one simple way that encryption can be implemented. By employing these techniques, Python developers can effectively secure their code by turning sensitive data into scrambled, unreadable information. This undecipherable text can only be made readable again through the parallel process, known as decryption. On this slide, we dive into two very important aspects of Python security, authentication and authorization. These components serve as tools to ascertain who can use your system and to what extent. Let's unpack that a little bit. Authentication, in the simplest of terms, is how your program verifies that someone is indeed who they claim they are. It is the initial line of defense, enabling users to prove their identities against stored data, for instance, usernames and passwords. Authorization, on the other hand, is the next step beyond identification. Once users prove who they are, authorization mechanisms come into play to dictate what exactly they can do or how they can interact with your program. It essentially determines if the authenticated user has the necessary permissions to access a specified resource. Python offers several useful libraries that can facilitate the implementation of these features. Libraries, such as Django and Flask, have built-in mechanisms for supporting authentication and authorization. This provides heightened security for your applications, ensuring that data is accessed and manipulated only by those who have the rightful claim to it. In the larger Python security scheme, the interplay of authentication and authorization is a critical part in ensuring a secure environment for your applications to run. It reassures your users that their data is safe and only accessible by those authorized. Understanding and correctly implementing these two aspects can help significantly in warding off potential security mishaps. Now, we are diving into Module 2, which is entitled Python Security Best Practices. The focus of this module is to provide you with a comprehensive understanding of how to ensure the safety, reliability, and efficiency of your Python applications. By the end of this module, you should be able to implement important Python security best practices into your own projects. We'll be covering some of the most critical aspects that are often overlooked by Python developers when designing and coding their applications. In order to protect your applications from external threats and vulnerabilities, it is crucial to have a deep understanding of not just the Python programming language, but also the methodologies and practices that contribute to a more secure development process. Whether you're an experienced developer looking to strengthen your security knowledge, or a newcomer to Python in search of guidelines for coding securely right from the start, this module has the insights and information you're looking for to make your applications more robust and resilient against security breaches. Let's venture together into the vast and fascinating field of Python security. Starting with an overview of the best practices, to provide you with a foundation from where we will further expand our discussions and exercises in this module. Welcome to Module 2, Python Security Best Practices. In this module, we're going to dive deeper into the realm of secure Python programming. Our aim in this module is twofold. Firstly, we want to share some proven practices that will help you to write safer, more secure Python code. This involves understanding a variety of best practices, such as minimizing the use of permissions for Python operations, using parameterized queries to prevent SQL injection attacks, and so on. Secondly, we are going to learn how and when to utilize Python's built-in security features. Python developers, as you may already know, have access to a wide variety of features and libraries, which can enhance the security of your applications. You'll get to understand the potential of these tools and how you can best implement them in your coding routines. In a nutshell, the end goal here is to make you a better Python programmer by teaching you how to reduce the potential for security vulnerabilities in your code. It's important to highlight that security must always be a consideration when creating software, and a deep understanding of these best practices can contribute to the robustness and reliability of your code, making it less prone to cyber threats and attacks. Let's dig in and see how we can start making our Python code safer and more secure in practice. In the current section of our course Python Security, Best Practices Part 1, we will focus on two important aspects: avoiding security misconfiguration and using parameterized queries. Firstly, it's crucial to understand that to avoid security misconfigurations, we must always use the least amount of permissions necessary for Python operations. This helps us keep safe from overly broad permissions, which can leave the system vulnerable. The second aspect we'll touch upon is the use of parameterized queries. These are an excellent and recommended practice for preventing SQL injection attacks. SQL injection attack occurs when an attacker injects malicious SQL code via user-provided data input. To help visualize, let's take a look at this example command: c.execute insert into numbers values num 2. In this code snippet, we're using a parameterized query to insert the values of num and num 2 into a table called numbers. By using we're specifying placeholders for our parameters, thus avoiding direct concatenation of user-provided inputs into the SQL statement. This type of coding practice goes a long way in protecting your applications from SQL injection vulnerabilities. This is just the start of Python security best practices. Stay tuned as we explore further these concepts in the next slides and learn more about user input validation and its role in maintaining the security of a Python application. On this slide, we are continuing on after discussing how SQL injections can be prevented through the use of parameterized queries. We now focus on another best practice: user input validation. A common source of security vulnerabilities can come from user inputs. Unsuspecting or malformed data can wreak havoc if not managed correctly. Fortunately, Python provides a built-in module, known as RE, for input validation. Using regular expressions, we can establish criteria that the input must meet. This way we can ensure that the data we are receiving fits the format and content that we consider safe. To demonstrate this concept, let's look at the example command shown here on the slide. Firstly, we import the RE module. Then we receive some user input, say, an email address. Using the re.match function in combination with appropriate regular expression, we can check whether the user inputted email address fits the expected pattern for an email. If it does, then we print valid email. This is a simple yet very effective way of validating inputs. When dealing with user inputs in your applications, remember this step to enhance your security measures and prevent vulnerabilities. With our focus on Python security, this slide moves our attention to another significant area using secure Python libraries, such as requests and HTTP.client. These libraries are extensively used for making secure requests. Secure in this context does not just imply a successful transfer of data over the network, it is much more encompassing. These libraries have inherent handling for protections against some very common, yet critical security attacks: cross-site scripting and cross-site request forgery. Guarding against such attacks is essential to maintain the integrity and safety of our data as well as our software system. Here is an example command that demonstrates the use of the requests library in Python. You'd start off by importing the requests library. Then you call the get method from the requests library to fetch a web page. In our case, we have chosen https://www.python.org. So, the command would look like this: import requests response equals requests.get//www.python.org. It's a simple and efficient way to send HTTP requests. Also, the fetched data can be further processed based on the application's requirements. As a Pythonista, you should be familiar with these libraries and use them wherever necessary to enhance the security of your Python applications. On our current slide, we are wrapping up Module 3 of our course, which is focused on Python security basics. To summarize the key points, we've discussed and explored how, despite Python being an extremely versatile and robust programming language, it's an absolute must to ensure the security of your code. One cannot overemphasize the importance of following best practices and applying secure coding principles to mitigate potential risks. It's essential to understand that a very critical aspect of writing secure Python code is the use of secure Python libraries. For instance, utilizing libraries such as requests and HTTP.client are highly beneficial as they are specifically designed for making secure requests. Built into these libraries are protections against significant security concerns, such as cross-site scripting and cross-site request forgery. To illustrate a simple use case, consider the example command, import requests response equals requests.get https://www.python.org. With this command, we're invoking a secure request to the Python's official website. This represents a fundamental application of Python's secure libraries. In our journey through Python security basics, we've learned that secure coding techniques are not optional add-ons, but rather, they should be integral to any coding process right from the start. It's our responsibility as ethical Python developers to stay vigilant and use the best available tools and practices to ensure the security of our code. Let's now sum up the insights we've garnered throughout this third module. We've discovered that although Python is a powerful programming language, close attention must be given to security. This is an integral aspect of any application or system built using Python. One key point that we've underscored is the importance of best practices and secure coding to safeguard against potential risks. It's clear that simply relying on the strengths of the language itself isn't sufficient. We, as developers, must continuously stay vigilant and uphold high programming standards to ensure that our Python applications are robust and secure. We've also recommended the use of Python security libraries as an effective line of defense. These libraries can greatly simplify the process of hardening your Python applications against threats. By adopting these practices and tools, we can make our Python applications more resistant to common security vulnerabilities. With this, we wrap up the module on the symbiosis of Python and security. Equipped with the knowledge and understanding gleaned, you can now confidently write secure Python codes and develop applications with an enhanced focus on security. All right, let's dive into the resources provided on this slide for Python security basics. As we've discussed throughout the course, a deep understanding and application of security principles is paramount when working with Python or any language for that matter. We see here 3 key references that you can bookmark to expand your knowledge and stay up to date on best practices. First, we have the Python documentation. This is an essential resource from the official Python website where you'll find in-depth content on all aspects of Python, including security. It's recognized as the most authoritative and comprehensive resource on Python. Next, we have a specialized website named Python Security. This website focuses strictly on Python security issues and best practices. It provides a plethora of information that includes vulnerability reports, security news, and solutions for Python applications. Finally, we have the Advanced Python Security MPL book available from Packt Publishing. This resource provides more advanced guidance on securing Python applications. It's a considerable tool for Python developers who are keen on stepping up their security practices in coding. Remember, the understanding and implementation of Python security is a journey, not a destination. So, continue learning and keep your Python applications safe and secure. Remember, all the references to these resources can be found in the course description.